All right, you guys. So, what do we see there? The Earth. Awesome. Halfway there, then. We got that much down. Earth is a planet. Earth is our planet. Earth is... How many planets out from the sun? That is incorrect. Wow. Yeah. I don't know if you folks at home can hear that, but... All right. Restarting here after some weird construction equipment downstairs. Yeah, it's the Earth. And I think I just asked, where are we in our solar system? And I think you had your hand up, sir. Third planet, yeah. There was a TV show for a while, Third Rock from the Sun, some folks know. But long before that, there was a really great song, Third Stone from the Sun, Jimi Hendrix. Whichever reference you happen to know, if either, that's us, okay? And we'll talk about that, maybe, if I go off on a tangent. What color is the Earth, at least in this picture?
Blue.
Primarily, which color?
Blue.
Blue with a little bit of green, as he said. Excellent. What's all that blue stuff? Water. Good. And what's the green stuff? Vegetation, and a little bit of brown is rock, right? Let's call it rock. What's that white swirly stuff on there? Is it just cool drawing there, board?
Cloud.
Cloud. Okay, even more general. What are we seeing around this Earth? Atmosphere. All right. And the atmosphere is as much part of the Earth as anything, especially from our perspective, because if that atmosphere weren't there, we wouldn't be here. We need it. It does not need us. All we've done is abuse it. But it is as much part of the Earth as anything is. And as such, we will talk about it a little bit. You may find yourself saying, oh, crap, is this weather class once I start talking? No, but we do need to learn a little bit about the atmosphere. All right? So investigating the Earth, we're going to start, out above the Earth. We're going to go deep into the Earth. And if we have the time, we're going to go back in time and talk about where the Earth came from. So, without much further ado. Oh, and so this is why they call us the blue planet, by the way. We're the blue planet. Because we are primarily ocean. So, space. Yeah, we're floating in space. And where does space start? You'll find out where space starts. Some of you will be surprised that space is a lot closer than you thought. And space is also a lot bigger than many of you may have thought. Again, some of that we'll touch on, definitely. Some of it we'll see. Much closer to us than space, we'll say in the upper realms of our atmosphere, which, as long as it's our atmosphere, it's not space, if you follow. We've got two things that we want to acknowledge. The magnetosphere and something called the Van Allen radiation belts. All right. And this is kind of generic verbiage on here. Let me see if I do have another slide. Okay, I do go into them a little bit. Right now, we just say that the magnetosphere, it gives us protection from the solar winds. Solar winds make the news every so often. Solar flares and then solar winds because of they mess with the cell phone signals and stuff like that. And then the Van Allen radiation belts, which are very important, but they trap. It says stops. They trap incoming cosmic radiation. This is also why it's actually kind of dangerous to be out in space in, say, this International Space Station and so on and so forth, is because, we're stopping this radiation from coming into the Earth, that means it's getting stuck out there. So there's like this extra high. Not great. All right, so we're going to focus more so on the magnetosphere. The magnetosphere is created by the Earth itself. It is a function of the rotating core. The core, as you'll learn a little while later, more in depth, is a mixture of solid iron and molten iron with a little nickel thrown in. And because the Earth is rotating, that molten is sloshing around the solid, and it creates an energy field. It's pretty neat stuff. Very also basic kind of physical science stuff as well. And what that does is creates a polarized energy field. All I mean by polarized in this case is think of a battery. You got a positive end and a negative end. You know it as the North Pole and the South Pole. Okay? And this energy field around us is very, very important. Without it, okay, we would not be. We would just been toasted long time ago. Whatever our predecessors, talk evolution or not, whatever we were going to become would never potentially have gotten very far, or it'd be significantly different, depending which lane you want to argue there. Neat thing about the magnetosphere is that, at least according to the rock record, which doesn't lie but can be up for interpretation, the North and South Pole, or the polarity, reverses itself every couple 100,000 years. And the way I just explained it to you, which is the correct way, that the magnetosphere is a function of the rotating core of the Earth, I really can't think of a whole lot of ways that you could flip the polarity without, what, if you ever played around with batteries as a little kid and little simple machines, to get the machine to go back, or the motor to go backwards, you flip your wires, right? So obviously the Earth hasn't stopped rotating and started rotating in the other direction every 200,000 years. We probably would have noticed some way, shape, or form. Yeah, the last time would have been when the dinosaurs were here. They weren't really good at taking notes. They didn't have thumbs. So, but we would have seen something in the rock record indicating something seemingly as catastrophic as that, right? So something's going on there, and in your book will talk about it. If you actually do the reading, you're going to see this magnetic banding on the seafloor, okay? And it's really neat stuff. We don't talk about it really any more than this, because they don't really have a great answer for it. At least from my mind, I want to know. I acknowledge that it happened. I want to know why, and there's not a great why yet. So, anywho. Oop, wrong way. It's a really cool spider from space, isn't it? Or space squid. I'm not sure which one. I think space squid. This is somebody's thesis project or doctorate, perhaps. What we see here, obviously, is the magnetosphere. All right. What's a little confusing is why it's shaped so strangely. What you got to look at is the way the Earth is oriented, which is hardly the focus of this picture. All right. The Earth is more or less up and down in here. It's tilted a little bit, 23.5. You'll learn that later. So your axis of rotation is really right through here. So what we see is the energy current from the magnetosphere radiating to the west and to the east, if you would. But because it's taking the solar winds with it, they drag it out on the opposite side of the sun. So that's why it just kind of streamers out, is the sun's energy is pulling it that way. So this is a really cool diagram. I mentioned to the folks in front of me that some version of this PowerPoint has existed since I've been teaching, which is like 25 years now. I've always taught this stuff. And this is a diagram we did not have back then. So, kind of cool. So the Van Allen belts, it's an area in the magnetosphere, all right? And the radiation gets hung up in there. You may have heard about carbon dioxide gets stuck in the atmosphere, okay? It doesn't escape very easily. Well, it's sort of the same thing that's going on here. So a lot of this incoming radiation, and this is a good thing, don't get me wrong, that it gets trapped. We want it there. But in the same sense, now that we're exploring out there, it's something we need to be wary of. Okay? So, yeah, it's an area. All right? It's not its own separate thing. It's in the Van Allen. I'm sorry, it's in the magnetosphere. But, and if you could imagine, Professor Van Allen is the one that found them. And Magneto found the other. No, he didn't. But, so, at any rate, yeah. As long as those are there, we know the magnetosphere is working. Nothing super intense here. But this is another nice way to show you, again, how the magnetosphere comes off from either side of the poles. Okay. So there's so many ways they refer to our atmosphere, and most all of them, there's no correct and incorrect, but gaseous bubble, you've heard the word envelope, maybe. The idea is that we've got a really, really thin layer around us, even more so if you narrow it down to what's livable for us. One of the things that these intro science classes love to throw at you guys are all those spheres. It's a hydrosphere, the geosphere, the this sphere, the that. Remember all those spheres? I don't use those because in my mind, half of them overlap the other ones and they blend, and there's no clear distinction. And maybe that's because I'm a systems scientist instead of I'm a generalist. But the atmosphere, okay, that is a finite thing. It ends at the surface, it begins at the surface, and it ends at a particular point. Yeah, it fades out, but it does have an end.
What's the other 1%?
A little bit of everything else. I think I got a better breakdown coming. So a lot of folks are surprised to find out that you're nitrogen breathers. All right. For the most part, back when I don't want to say found this out, but when I found myself in a position of explaining it to y'all, I quizzed my bio buddies. I'm like, all right, I know about the bends, but otherwise nitrogen, us. And they're like, doesn't really do a whole hell of a lot. You know, a couple things here or there, but mostly it just passes through you inertly. We like the oxygen. I'm like, yeah, I know we like the oxygen. So, think of the nitrogen as just sort of like the background matrix holding everything else in place there. We need that oxygen. All right, 21% doesn't sound like a whole heck of a lot, right? You brought home a test with a 21% on it. That's not great. But it's just right. And you're going to hear that over and over again. We're going to talk about CO2 a little later maybe, and you're going to see it's a really tiny number. You're going to say, what the hell are they worried about? Whatever it is, big or small, it's what it's supposed to be or near it. And that's what's important. Because he asked about where's that other 1%. It is a fixed volume. And as you get rid of one thing, you have to make room for something else and so on and so forth. And it's all got to give. So you may or may not have had the opportunity to go somewhere where there's a little less atmosphere. I was out in California over the summer, up a good 5,000 plus feet, which is a little over a mile, and hiking. For those of you that haven't seen me, I'm not a skinny man. So I was just writing it off to, I live at 200 feet above sea level on a fairly flat area. I'm just way out of shape. But I really, in retrospect, started to realize after I got back from California that, there's that much less air up there. And it's not varying the percent oxygen, but it's how much, we'll talk more about that in a minute. But oxygen is important, all right? Sidetrack, sorry. If you go up to 22, you notice it. You may have heard some rich weirdos go in these oxygen tents for just, nutritive purposes. And they pump the oxygen up to 22, 23% maybe, and their bodies go crazy. If you find yourself dipping down 20, 19, okay, your body freaks out really quick. Everybody became familiar with oxygen sensors over COVID, right? Because you had to check your dissolved oxygen in your blood and everything like that. You don't mess around with oxygen. So again, it's not a huge percent, but it's set exactly where we need it. All right. The atmosphere is held to the Earth by gravity. That's super important. You're going to see that on the test. Why do we have an atmosphere? We have an atmosphere because we have gravity. All right. Why doesn't Mars have an atmosphere? Well, it does. It's just nothing compared to ours because Mars is half the size of us. Yeah.
Do you think one day we'll be able to live on Mars?
Oh, yeah. We could live there now, just nobody wants to. Criminy. They had, it's going to be, who's Virgin? Branson. It's going to be Musk. There's a couple other contenders. They privatized this years ago, and I was super upset back then. I didn't really understand the money that was in the private sector. You can't do this on government money. It's not happening. So they had people lined up. It was good 5 years ago. New York, LA, one of the places, literally around multiple blocks signing up to be the first colonists for, I forget what it's called. But I think it was Richard Branson's flight. We've got spaceport. There's a spaceport out in Nevada, I think. There's probably a couple now. The thing about Mars is, you're going to be in habit trails the whole time. You're going to be in gerbil tubes for 95% of your life. You go outside, you're going to be in a suit. It's going to suck. It really is. We're going to do it as proof of concept, I have a feeling. But more so, I think what we're going to see, and this is the super neat part about it, all this raving about ice on Mars. I'm like, okay, cool, they'll be able to melt it and we'll have drinking water. No, it's not about that at all. It's about hydrogen fuel. So they're all excited about ice on Mars. It's going to be another space station is what it's going to be. It's going to be a waypoint, more than likely. But a ways. The other problem is getting there. It takes so long to get there. It's like 90 days. It's like 3 months. I could be off, though. My brain's foggy lately. But I think it's about a good 3 months or it's 90 days or 9 months. And I can't remember which one. How long does it take to get to Mars? Tax refunds? Really? How long does it take to get to Mars? 150 to 300 days. On alignment, yeah. Thank you. So 30 divided by 150 is 5 months. Yeah, 5 to 9 months. So I was off with the 3. So it's right around 9 months, depending on what order everything's in when you launch and everything. So it's a long haul. That's the other thing. It's not where we need to go into deep sleep or anything. It's just gonna be really boring again. So, but people, like I said, would pay good money to do it regardless. All right, anywho. Why do we have an atmosphere? Gravity. Good. All right. What else is important at this point? A wonderful thing called the ozone layer. The ozone layer. When I was a kid, we almost lost the ozone layer. Well, we didn't almost lose it, but we had some pretty big holes in it. You may have heard about this. And it was all blamed on Aquanet and coolant. So they fixed that problem by getting rid of a handful of nasty chemicals, chlorofluorocarbons, one of the big bad guys. And we actually banded together almost as a world and fixed the problem. It was really, really cool to see that happen. First world countries, primarily. You'll still see a lot of this stuff in the third world countries, but even though they're quite densely populated, it's still not as bad as it was. So we fixed that. Why do we like the ozone layer? Anybody want to remind us?
Stop us from getting burned.
From?
UV rays.
Yeah, UV rays. All right. Ozone, which is O3, by the way. O2 is what you breathe. Ozone is O3. It's in the stratosphere, which is actually on the slide here, which is one level above where you live, which is the troposphere. The ozone blocks out UV rays. So in our defense shields, if you would, I always get Star Wars references. I'm not like as big a nerd as there can be, but I'm Star Wars references, and to tell you that I'm not a nerd, it's because my references are only about movies 3, 4, and 5. So all the other ones are just, they're cute. But so Obi-Wan turning off the force fields so, they could get in. You've got these protector beams up. We've got the magnetosphere, and we've got the ozone layer. They filter out two different things. All right. The ozone layer is there for ultraviolet radiation. Why don't we like UV rays? What do they do to cells? They don't just give you sunburn. UV rays cause mutations, which we call cancer, yeah. They can cause cells to mutate or go about their reproduction incorrectly or poorly, and yeah, we tend to call that cancer, okay? So we want to make sure that those don't get through either. Rather fortuitous that it's there. All right, so I hear you guys starting to wrap up, and it is indeed time. But just to review this, because we went off on a couple of tangents here, the atmosphere is primarily nitrogen with almost a quarter oxygen in it. We have an atmosphere because we have a gravitational pull. We have a gravity. One of the important layers in the atmosphere is the ozone layer. It's important because it filters out UV, which stands for ultraviolet radiation. That lives in the stratosphere, which is one level above where you guys live, which is called the troposphere. And if you remember that Red Bull guy jumping out of some sort of satellite-y thing, a rocket thing a few years back, he actually made it to the stratosphere and jumped down. That was what was so crazy about that, amongst other things. But scientifically speaking, that was a stratosphere jump, which is pretty insane. All right, so we'll wrap it up here, and we'll pick up later.